Now, students, this is regarding exponential function. This video will help you in understanding the exponential function part. We also have lots and lots of confusion regarding exponential functions. Sometimes we get confused that what kind of functions are called exponential functions. Is it so that e to the power x are the only ones which are called as exponential function? The answer is no. So let us now try to understand what exponential function is. A real valued function f, that means we can take any real value replacing this x part. A real value function f defined as fx is equal to b to the power x. Fx is equal to b to the power x. What is b here? This is very important. Value of b should be greater than 1. So any function which is in the form b to the power x where b is greater than 1 is called an exponential function. So these kind of functions are called exponential function. I'll come to this point why we say that b is greater than 1. Now, when we talk about this form, fx is equal to b to the power x form, we can replace b by 10, we can replace by e, and we can replace b by any real value greater than 1. But these two, that is particular value of b, that is for b is equal to 10 or b is equal to e, we give a special name. So when b is equal to 10, then fx becomes 10 to the power x, which is called as common exponential function. And when the value of b is equal to e, so we have already discussed in last video regarding what e stands for. So in that case, fx is equal to e to the power x is called as natural exponential function, and this is what you will be learning, and you will which is there in your textbook also, and you will be learning more and more regarding fx is equal to e to the power x form. So that is called as natural exponential function. So in short, either we write it in the form of 10 to the power x or e to the power x or fx is equal to b to the power x. These all are examples of exponential function. Now try to understand more about this function. So there are some silent features of exponential function which I have listed it here, and you all need to go through it one by one. So the first thing is the domain part of the exponential function is r. Now you see here, students, here we can replace x by any real value. Can be 0, can be from 0 to infinity or 0 to minus infinity. We can replace x by any real value. Here you can see I have plotted the graph of exponential function. The value of x here on x-axis is from minus infinity to infinity. You go on taking the values, it will there is no such value for which this function is not defined. So we say that function domain part of the exponential function is r. Now what about this range part? Range of the function is positive real number. Why we say positive real number? Now this will become very much clear to you from this part. Here I am focusing on that the value of b should be greater than 1. Once the value of b is greater than 1, any value which is greater than 1, say for example 1.1 raised to the power, any power you take, you take the power 1 or 2 or 3, or you may take negative power minus 1, that will stand for 1 by 1.1. If you take any value 2 to the power minus 2, it will stand for 1 by 2 to the power 2. So in any such case, you will never get a negative value of y. These all are positive values. It will never be a negative value. Therefore, we say that the range of the exponential function is a positive real number. So we will always get a positive real number when we talk about range of this exponential function. The third point, very important to note, that 0, minus 1 will always lie on the graph of exponential function. When you plot the graph of exponential function, whether you talk about b to the power x form or 10 to the power x form or e to the power x form, if you replace x by 0, you will get b to the power 0, which is 1. You will get 10 to the power 0, which is 1. You will get e to the power 0, which is 1. So in each case, 0, 1 will be a point on the graph. Here also, the graph part which I have drawn here, I have shown that it is passing through 0, 1. So 0, 1 will always be a point on the graph of exponential function. Next thing is, it's an ever increasing function. It will never show decreasing trend. As you increase the value of x, it will always be an increasing function, and obviously it is continuous also. Now you see here, when you increase the value of x, what is happening? The value of y is also increasing. The value of y is increasing. With the increase in the value of x, the value of y is also increasing. So it is showing an increasing trend. It will go on and on. It will increase. So that's why we call it as ever increasing function. And the last point is very important. That is when x approaches minus infinity. Now consider the situation when we talk about fx is equal to b to the power x. Let us take this example, fx is equal to 10 to the power x, because here in this case we have a constant base, that is 10. So if I take 10 to the power x part is, here I have written when x approaches in minus infinity. That means I take suppose minus 1 followed by so many zeros. So 10 to the power x, and where x is minus infinity, so the value will be 10 by 1 followed by those number of zeros. So these many zeros will be there, because you know that in laws of exponent you must be knowing that x to the power minus 1 is 1 by x. So this to the power, this is 10 by, this power will come, the power will come here. So we can write, sorry, here I did one mistake. This can be written as 1 by 10 to the power followed by so many zeros. Because in law of exponent you have learned that 2 to the power minus 1 is 1 by 2. 2 to the power minus 1 is 1 by 2 square. So 10 to the power minus this is 1 by 10 to the power this. So now you imagine 1 is divided by such a large value. So 1 divided by a very large value will give you a value which is very close to 0 but will not be exactly 0. So therefore we say that if I take the value of x minus of infinity side, this side, the value of y, this one, will be almost equal to 0, but it will not touch this axis. So in this is called as the second quadrant. So x-axis along the second quadrant, it will be almost touching that x-axis but will not be meeting it. So that's what I have written over here, that the graph approaches x-axis in second quadrant but will never meet it. The graph will never meet this x-axis part. It will approach 0. So these are some important things to note regarding exponential function. And this is very important, that this part which we are focusing in our syllabus, that is regarding natural exponential function. That doesn't mean that these two are not the examples of exponential function. These all are example of exponential function. Any function which is of the form b to the power x, where b is greater than 1, is called as exponential function.